Hi, my name is Norberto, and I'm an applications engineer at Maxim Integrated's eSIM team. Choosing a DC-DC converter for your application can be a daunting task. Finding out if a particular DC-DC converter can meet your application requirements requires you to thoroughly read the datasheet in order to make an educated decision. Before any simulation or testing can be done in the lab, one would like to know if the chosen DC-DC converter can meet the application requirements. eSIM's automatic design verification saves time that would otherwise be spent on tinkering with the part in the lab that does not conform to an application. The Design Requirements tab in eSIM embodies a live version of the particular part's datasheet. Of course, it's always recommended to review a part's datasheet to understand the electrical characteristics, absolute maximum ratings, and any particular precautions you need to account for when using the part. To put this into perspective, let's look for a DC-DC converter that supplies 5 volts and 1.25 volts from a 3.3 volt source. Sometimes certain architectures and converters require a minimum amount of time to recharge the bootstrap capacitor, which drives the high side and fit switch, properly sense current used for current mode control, and account for blanking time. A minimum on time sets the minimum duty cycle. This means that the buck converter is constrained to a maximum line voltage and a minimum output voltage for a specific switching frequency. If your application requires a duty cycle that is smaller than the minimum set by the converter's minimum on time, that converter may not provide the regulated output voltage required by your application. One way a boost converter limits the allowable output current is by setting a maximum limit on the magnitude of the current that flows through the internal low side switch. Because a boost converter steps up in input voltage, a considerable amount of input current is required to regulate the desired output voltage. This input current, which is stored as magnetic energy in the inductor, may be large enough to exceed the maximum current limit of the internal low side switch. The ideal duty cycle equations let you know when you're operating your converter near 100% or 0% duty cycle. However, the ideal duty cycle equations do not include the power loss of the converter. Conduction and switching losses effectively increase the power required to regulate the desired output voltage for your design. The design requirements validation in eSIM lets you know if you'll be operating near the minimum boost duty cycle and the maximum buck duty cycle by taking into account efficiency. Why are the maximum or minimum limits on the duty cycle important to know? Operating near these two conditions may result in your output voltage falling out of regulation, especially during transient events. Over time, having your buck converter or your boost converter operate near 100% or 0% duty cycle may be detrimental for your design. If a power converter was not designed to handle the peak current stresses that happen when starting up at full load, reliability may be a problem in the long run. The Design Requirements tab actively verifies your input design requirements and does not let you create a design if any guideline in the datasheet is not met. eSIM provides error messages when the current state of the design requirements cannot yield a working design with the chosen part. Warning messages also appear as a cautionary tale for the designer to take note when verifying the hardware in the lab. Every text field on the Design Requirements tab will display an error or a warning message if the requirement is beyond the part's capabilities. The message includes an explanation of the error or warning message and may also include a way to resolve it. In order to create a design, all error messages must be resolved. The Design Requirements tab guides an eSIM user to create a working design that meets the application requirements. No more fuss with datasheet equations means less time trying to figure out if a part will work and more time characterizing your power converter for your design. Rest assured that your design will be a working design when using eSIM.